So hello everyone, my name is Anmol Saini and I am your chemistry SME. Today we are solving BTP 23 questions. Okay, so let's start. So first of all, question number 51. Uh, Here we are given with the two statement. First is we have CH3 CH2 COOH is less acidic than Cl CH2 COOH. Okay, so here we know that here plus I group is present and here minus I group is present. So minus I will increase the acidic property. So the statement 1 is correct. And the statement 2 written is plus I group increases the acidic strength. No, this is wrong. Minus I group will increases the acidic strength. So statement 1 is correct, but the statement 2 is incorrect. So option number 3 will be our correct answer. Okay. Option number 3 is our correct answer. Now question number 52. Here we are given with here we have to find out the stability of the keto and the enol given molecules. Okay, so here we have molecule 1, 2 and 3. Okay, so by clearly analyzing we can found that there is a conjugation between this double bond, this single bond and this double bond. Due to this conjugation and after this conjugation hydrogen bonding can also form here, and due to the conjugation and the hydrogen bonding, third one is the most stable. And we also know that in the keto and enol form, keto form is more stable than enol form. Okay, so third is more stable, is the most stable. Then we have first, then we have second. In first and second, because keto is more stable than enol form. Okay, so the option number 4 will be our correct answer. Okay, now comes to question number 53. In question 53, which of the following present the correct order of acidicity in the given compounds? Okay, so here we are given with FCH2COH, ClCH2COH, then we have BrCH2COH, then we have CH3COH. Okay, so here nothing is present. Okay, so it is a neutral compound. Here Br, here Cl and here F. Okay, so increasing the plus I effect will increase the acidic property. Okay, so which one will have the highest plus I effect, highest minus I effect, sorry. So the highest minus I. Now question number 54. Aldehyde and ketones on reaction with NH2OH produces oxime according to the following reaction. Okay, which of the following ketones on reaction with NH2OH may produce geometrical isomer? Okay, so first of all, for geometrical isomer, we just have to find which compound is unsymmetrical. Okay, if the compound is unsymmetrical, if the compound is unsymmetrical, then it will definitely form geometrical isomer. Okay, but if the compound is symmetrical, then it will not form geometrical isomer. Okay, so we have to find which compound is unsymmetrical. Okay, so in option number 1 you can clearly see that this compound is symmetrical. So this is the line of symmetry present here. In option number 2, we have CS3, CO, and then we have CS3. Okay, so CS3, CO, CH3. So this compound is also symmetric. Okay, so option number 2 cannot be our answer, 1 cannot be our answer. Then option number 3, this compound is also symmetrical. So option number 3 cannot be our answer. But if you see option number 4, there is no symmetricity in this compound, definitely form the geometrical isomerism. Okay, so option number 4 will be our correct answer. Okay, option number 4. Now question number 65. Option number 50. Question number 55. Which of the following product is not obtained during Kolbe electrolysis of sodium ethonate? Okay, so first of all, the chemical formula for sodium ethonate is CS3, C double bond O minus and then Na plus. Okay, now in Kolbe electrolysis. Okay, so in Kolbe electrolysis, first of all, this negative charge and Na plus will separate out like this. Then there will be two separate reaction in the anode and the cathode. Okay, first of all, in the anode we have CS3CO O minus, then it will uh, after two electrons it will form CS3 CO, then O radical, and then further it will form CS3 radical, and then CO2 gas will be released. Then further these CS3 radical will join and form uh, ethane. Okay, and a separate process will be carried on cathode. It will be H2, then 2 electron, and it will form OH minus and H radical. Then H radical will join and form hydrogen gas. Okay, so we have to find which of the product is not formed. Okay, so CO2 is formed, H2 is formed, and C2H6 is also formed. So the correct answer will be option number 2, which is oxygen, O2. Okay, oxygen will not form here. Okay, now question number 56. Okay, we are given with pH, we are given with benzaldehyde, reaction of benzaldehyde with CS3 C double bond O H in presence of OH minus and heat. Okay, so this is aldol condensation reaction, very famous reaction of organic chemistry, which is aldol condensation. Condensation reaction. Okay, so here is one compound and there is another compound. Okay, so there are four possible product for this reaction. Okay, so here we have to find which is the major product. Okay, so for the major product, we can clearly write pH, then we can write C double bond O, then H, then we have C double bond O, H this side, and then CH3. Now this O2 molecule will separate out and heat is also present. Okay, so it will form pH, C double bond C H C H O. So this will be the major product, and the product is formed by the cross aldol condensation reaction, because two products are there. That's why the reaction will be cross aldol condensation reaction. Condensation reaction. Okay. So the correct answer will be option number A. Okay. So the next question is question number 57. Okay. The Cannizzaro reaction is not given by. Okay. So first of all, we have two important reactions. One is the aldol condensation and the another one is Cannizzaro reaction. Aldol condensation is given by the compound which have alpha hydrogen, which have alpha H. But Cannizzaro reaction will be given by the compound which do not have alpha H, which do not have alpha H. Okay. So we have to find which compound here have alpha H. Okay. So clearly option number B don't have alpha H. Then option number A also don't have alpha H. Option number D also don't have alpha H. But option number C will have alpha H. Okay, so this can't give Cannizzaro reaction. This can give aldol condensation reaction. So correct answer will be option number C. Correct answer option number C. Yes, option number C. Now comes to question number 58. Here question number 58 is we are given with a compound, then we have a NaOH plus I2 iodoform reaction, then a yellow PPT will form, then compound C will react with the tolerance reagent to give the positive tolerance test. Okay, so here we can clearly find, first of all we have to tell it will give the tolerance test, and we have to find the iodoform reaction. Okay, so clearly here we can see which of the following product can give the iodoform test. Here we have to find the compound A. So clearly option number D, it cannot give the it will not give the our iodoform reaction because it is a ketone. Okay, then option number C, it is also ketone, it can't give the iodoform reaction. Now we have to find between the option number A and the option number 2, but here uh, we have H C double bond O H, and here we have CS3 C double bond O H. But for the iodoform reaction, we have to find CH3 C double bond O group. Okay, so this can give our iodoform reaction. Then further we have to find the tolerance test. So this will also give our tolerance test. Okay, this will also give our tolerance test. Hence option number 2 will be our correct answer. Option number 2 will be our correct answer. Now question number 59. Arrange the given compound in order of decreasing reactivity for nucleophilic addition reaction. Okay, for nucleophilic addition reaction. Okay, this is also a very simple question. For the nucleophilic addition reaction, we just have to see the least electrophile center. Okay, so order of nucleophilic addition reaction depends upon electron withdrawing group. Electron withdrawing group. If electron withdrawing group is present, then it will be directly proportional. If electron donating group is present, then it will be inversely proportional to the electron donating group. Okay, if the higher the order of electron withdrawing group, then there will be very increase in the nucleophilic addition reaction. Okay, so here we have to find, first of all we are given with CS3, then we have CS3 on this side. So now in option 1, here plus I effect is there, here one more plus I effect, but Cl is providing the minus I effect. Okay, in option number 2 we have minus I effect, and then here we will have plus I effect. In option number C, it is a neutral compound, it is not applying any plus I or minus I effect. But in option number 2 we have two plus I effects, we have two plus I effect. Okay, so we have to find the decreasing order. Okay, so most the compound which give the most nucleophilic addition reaction among these will be option number 3 will have the highest order. Then we have option number then we will have option number then we will have option number 2, then we have option number 1, and then we will have option number 4, because here 2 plus I effect is there. In option number 1, 2 plus I effect is there, but Cl is also present, and Cl is present after the CH2 group. Okay, so the order of minus I effect will decrease, slightly decrease. Okay, so the correct order will be option number 2. So correct answer is option number 2. Now comes to question number 60. Assertion is ketones can be converted into acid by haloform reaction. Okay, and the solution is present here. So first of all, in the haloform reaction involves the conversion of methyl ketone into a carboxylic acid. This reaction requires the presence of a halogen and a base. Okay, so our assertion is correct. Okay, now we have to check for the reason. The addition of Grignard reagent to dry ice followed by hydrolysis give ketones. Okay, okay. So here the addition of Grignard reagent to dry ice followed by hydrolysis give carboxylic acid, not the ketones. The reaction is given here. First of all, we have the RMGX, then we have the dry ice. In the presence of dry ether, we will have the Grignard reagent, then it will be formed RCOOMGX. then this MgX group will leave, and carboxylic acid will form. COOH group will form. Okay, so here carboxylic acid group will form, ketones will not form. So reason is incorrect. So assertion is correct and the reason is incorrect. So option number C will be our correct answer. Now question number 61. Which of the following compound will give butanol on oxidation with alkyl KMnO4? Alkaline KMnO4. Okay. So first of all, alkaline KMnO4 is a strong oxidizing agent. Okay. And we have to find butanol. So we have to make ketone. Okay. So we have to make ketone. So in the presence of alkaline KMnO4, only 2-degree alcohol, 2-degree alcohol can give our ketone. Okay, so we just have to find the which of the following option will have the 2-degree alcohol. In option number 1, it is a primary alcohol. In option number C, it is also a primary alcohol. And in option number 4, it is a cyclic compound. Okay, so this cannot be our option. 1 cannot be our option. C cannot be our option. But in option number 2, we have 2-degree alcohol. So it can definitely give ketone. Okay, so option number 2 will be our correct answer. Option number 2 will be our. Now question number 62. The order of reactivity of the following compound with with pH MgBr is. Okay, so we have to find the order of reactivity. Okay, so for order of reactivity with pH MgBr, it is based on the electrophilicity of the carbonic compound and the steric hindrance present on that compound. Okay, so first of all, electrophilicity and the steric hindrance will be used. Okay, so the first compound is pH, CO, pH. There is two major phenyl group which provide very hard, very more steric hindrance. Okay, and the another compound is CS3, C double bond O, H. There is steric hindrance only by one CS3 group. And option number 3, we have steric hindrance by two CS3 group, one CS3 then two CS3. Okay, so it will be the fastest for the option number 2, then we have option number 3, then for option number 1. So the correct answer will be 231, 231, 231. Okay, so option number 4 will be our correct answer. Now question number 63. Question number 63. Here we have to find the product C in this given reaction. Okay, so here we have given with the benzene, then we have nitro group, nitrobenzene, and then we have in para position we have chlorine. Okay, so first of all the reaction with Mg in dry ether. Okay, so here it is Grignard reaction, Grignard reagent. We are using Grignard reagent as a reactant, and then we are okay. So first of all, for the Grignard reagent, it will form benzene. Then we have NO2 on this side. Then MgCl will form after the Grignard reagent. Okay. Then we are given with the CO2 and H3O plus. H3O plus means H plus H2O. H plus H2O. Okay. H plus H2O. Now MgCl in presence of CO2 and H plus OH. H plus H2O, H plus H2O, it will oxidize. This MgCl group will leave and this side will oxidize to carboxylic acid group. Okay, so the product will be NO2 on this side, and then we have COOH group on this side. Okay, so there will be no change on the nitrogen group, but this side it will be oxidized to carboxylic acid group. Okay, so option number 3 will be our correct answer. Now question number 64. Question number 64. Okay, so here we have the match the following question. Okay, so first of all we are given with the ketone group, then we are given with ZnHg in presence of HCl. Okay, so it is reducing the carboxylic group. Okay, it is reducing the carbonyl group. Okay, and this reagent is Clemmensen reduction reagent. Okay, we know that Zn and Hg is used to reduce the compound, and this reaction is known as Clemmensen reduction. Okay, this reaction is known as Clemmensen reduction. In option number B, we are given with the carbonyl compound, Then we have NH2 group. Okay, NH2 group. It is also reducing, and this reaction is known as Wolff-Kishner reduction. Okay, in option number C, we are given with CN and it is going to NH2 group. So this reduction is doing by dibyl H. Dibyl H is used to reduce CN group in CHO group. Okay, and on last we have carboxylic acid group, and this carboxylic acid group is reducing to 1 degree alcohol, which is primary alcohol, and this can be done by a strong reducing agent, which is lithium aluminium hydride. Okay, so option number 4 will be our correct answer. Nucleophilic addition reaction. Okay, so as I have discussed earlier, for nucleophilic addition reaction, it will be directly proportional to electron withdrawing group and inversely proportional to electron donating group. Okay, electron withdrawing group, electron donating group. Okay, so first of so here we can directly found which compound is most electron withdrawing, so it will be the highest. Okay, so here we are given with just benzaldehyde, here we are given with benzaldehyde and NO2. NO2 group is a strong minus I effect. Okay, strong minus I effect. Here we are given with the benzaldehyde with plus I effect, and here we are given with benzene, then CO, CH3. Okay, so the compound with the most electron withdrawing group is option number 2. Hence, it will give the highest reactivity towards nucleophilic addition reaction. Okay. Now comes to question number 66. Which of the following reaction have the same number of carbon in reactant and the product? Okay. So we are given with the 4 reaction. Okay. So let me show you here. So the first reaction is electrolysis of CH3 CH2 COO Na. Okay, sodium propionate. Okay, so we have to do the electrolysis. On doing electrolysis, there the C double bond O Na group, O negative, Na positive, this group will leave out, and here CH3 CH3, this group will leave only left, and then this CO2 will be separated out and NaOH will form. Okay, so here the number of carbons are not equal. Now in option number 2, we have soda lime decarboxylation. Okay, so here CH3 CH2 COONA. Okay, in presence of soda lime, this COONA group will leave, and this group will form Na2CO3, which is sodium carbonate. Here the number of carbons are not equal. In option number 3, we are given with the Wurtz reaction. So in Wurtz reaction, we directly know in presence of diether in any, Wurtz reaction will take place, and Wurtz reaction just doubles the number of carbon, so it cannot be our answer. So option number 4 will be our correct answer. Let's see how. Here it is dehydration of ethanol. Dehydration of ethanol. Ethanol is present, CH3 CH2 OH. Now in presence of concentrated H2SO4, this OH group will leave and ethane will form. So number of carbon will be remain same. So option number 4 will be our correct answer. Now question number 67. Question number 67 is also very easy. Which of the following is not the product form? Okay, so here we are given this compound 1, here we are given with the compound 2, and this is dilute NaOH in presence of heat. Okay, so clearly this is aldol condensation reaction again, aldol condensation. And more precisely it will be cross aldol condensation. So here four products are possible. Four products are possible. How? First of all, this the compound with compound 1 with its self compound form product 1, then compound 2 with its self compound, then compound 1 with compound 2, and then compound 2 with compound 4. Okay, so here four such products are possible. If you draw all four, you will check option number 2 will not form. Okay, so option number 2 will be our direct answer. Okay, so as I have also already show how to do the aldol condensation, so this question will be very easy. Question number 67, very easy question based on aldol condensation. Now question number 68. In question number 68, we are given with this compound. Then first reaction is I2 in presence of NaOH. This is iodoform reaction. Then after iodoform reaction, we have H plus and heat. Okay. So first of all, iodoform reaction. So clearly on this methyl group, we know for the iodoform reaction we require CS3, C double bond O. This group is required for the iodoform reaction. Okay. So this group is present on this side. Okay. So here it will be oxidized to carboxylic acid. Okay. So the product shown is here. This carboxylic acid will form, and after this we have heat. Okay. After this we have heat. In heat, this from this carboxylic acid, water molecule will be separated out, and it will just carbon atom will remain. Okay. Just carbon atom will remain. Here we have COH group, here we have methyl group and double bond O. Okay. When we will give heat, water will be separated out and only carbon will be present. This whole group will be separated out. Okay. So this methyl group is present only, so this will be our present. This why this COH group is left? Because of heat, the water will be dehydrated. Following reaction would produce secondary alcohol. Okay. So we have to find the secondary alcohol. Here, here in all the option we are given with the carbonyl compound, C double bond O, C double bond O group. Okay. So first of all, we can clearly say that from ketone, from ketone, we can make 2-degree alcohol, or you can say secondary alcohol, 2-degree OH. Okay. So this can be possible by reduction of ketone, by reduction of ketone. So first of all, we have to find out the ketone, then we have to find out the reduction. Okay. So clearly, we know that lithium aluminium hydride is used for reduction. Here also lithium aluminium hydride is used for reduction. Okay. So either option number 2 or option number 3 will be our correct answer. But in option number 3, we have aldehyde. Aldehyde will give 1-degree OH. It will give 1-degree OH. But we need 2-degree OH. In option number 2, it will give 2-degree OH because it is ketone present over this. So it will produce 2-degree OH, which is our secondary alcohol. So option number 2 will be our correct answer. Now question number 70. Question number 70. We have CH3COOH. We have ethanoic acid. First we are reacting with NH3 and heat. Okay. So ethanoic acid, in presence of NH3 and heat, it will form CH3, C double bond O, and then NH2. Okay. Then we have P2O5 and then heat. Then P2O5 and heat. P2O5 and heat. It will remove this and it will form CH3CN group. Okay, CH3CN group. Then we have lithium aluminium hydride. Lithium aluminium hydride is a strong reducing agent which will it will reduce it. It will form CH3, CH2 and then NH2. So correct option will be CH3, CH2, NH2. Option number 2 will be our correct answer. Now question number 71. Okay, question number 71. In question number 71, we are given with the pH, C double bond O, then we are given with CH3, and then reactant is NaOCl in presence of heat. Okay, so NaOCl in presence of heat, what it can do? Okay, so first of all here CH3 group will leave, and then pH, C double bond O, O minus, and then Na group will, Na positive, this group will form. Okay, and then we as a side product CHCl3 will also form because of this reagent, which is NaOCl. Now this reagent on the reaction with aniline, this reaction on this reagent on reaction with, no, there is not aniline. Yes, there is aniline. There is aniline. We have benzene ring, and then we have NH2 group present on it. Okay, so this compound will form isonitrile group. This compound will form isonitrile group. In presence of NH2, it will form NC group, which is isonitrile group. Will form. Okay, so option number D will be our correct answer. Sulfuric acid. Okay, so first of all, the reaction which do not have an alpha H. Okay, and it is disproportionation. Okay, So it is giving us the full idea. It is talking about the Cannizzaro reaction, because in aldol condensation there we have alpha H, but here it is talking we will not have an alpha H. Okay, so it will be the Cannizzaro reaction. Okay, the reaction described where the aldehyde without an alpha H undergoes self-oxidation. This is known as Cannizzaro reaction. In Cannizzaro, two molecule of aldehyde without alpha H reacts in presence of a strong base produce molecule uh, uh, in which one is the carboxylic acid and another one is alcohol, which is known as disproportionation. One is oxidation and another is reduction. Okay, so option number 1 will be our correct answer. Now question number 73. Okay, we are given with a compound, and first we are reacting with dilute H2SO4 and HgSO4. Okay, so the compound is pH C, then we have CH group. Okay, in presence of dilute H2SO4 and HgSO4. Okay, so in presence of dilute H2SO4 and HgSO4, it will form the amide group. It will form C double bond O CH3. Sorry, it will form the ketone group. It will form the ketone group. Here it will oxidize it. The triple bond will oxidize, and it will oxidize in ketone group. Okay, oxidize in ketone group. Now here it is the compound A. Now compound A on reacting with the benzaldehyde. Compound A on reacting with benzaldehyde. It is a very famous reaction. Compound A with the benzaldehyde. So here in this reaction we have OH as the reactant in presence of heat. Okay, OH in presence of heat, and here we have alpha H on this compound. So it will be the cross aldol condensation. Cross aldol condensation. Cross aldol condensation. Okay, so after the cross aldol condensation, here this is our product A. This is our product B. This is our product B, and after this reaction, compound A, compound B, then we have cross aldol condensation, and after the heat this compound will form. Okay, so option number 2 will be our correct answer. Okay, now comes to question number 74. So question number 74. So first of all, this is the match the following question, in which the first option is acetone and aldehyde. Okay, so acetone and aldehyde can be separated with. Okay, so acetone and aldehyde, it can be separated with NH4Cl and AgNO3, which is our Tollen's reagent. Okay, one is our ketone and one is aldehyde. Tollen's reagent can give the silver mirror test for the aldehyde, but no reaction for acetone. So this can be separated. Okay, so option number A will be matched with R. Okay, now we are given with the methanol and ethanol. Okay, so methanol and ethanol can be separated by iodoform test, because methanol can give the iodoform test but ethanol can't. Okay, so it can be separated with S. Okay, now phenol and cyclohexane. Okay, phenol and cyclohexane can be separated by using bromine water test. Okay, because one is a aromatic compound and another one is aliphatic compound. Okay, option number C is sorted. Now option number D, we have N-pentane and we have 2N-pentene. Okay, so one is having the single bond and another one is having a branch and a double bond. So this can be separated by alkaline KMnO4, or you can say Bayer's reagent. Okay, Bayer's reagent. So correct option will be option number 2. Now comes to question number 75. Question number 75 is also the match the following question. First question is a very famous reaction R C double bond O Cl, which is acyl halide, and it is giving RCHO. Okay, RCHO. So this is a very famous reaction, which is also known as which is it is a reduction reaction first of all, which is done in presence of H2PD BSO4. H2PD BSO4, and this reaction is Rosenmund reaction. Rosenmund reaction. Okay, so option number A is matched with option with 2. Okay, now we have RCH2COH, and here Cl group is attached. So Cl group on the alpha position. Okay, Cl group on the alpha position. So this can be done only by the Hell-Jonard-Zalesky reaction. Okay, and the reagent are Cl2 in presence of red phosphorus. Cl2 in presence of red phosphorus. It will create the Cl on the alpha position of the carbon. Okay, so option number B matched with option with 4. Okay, now we have amide group. Amide group is giving RCO, NH2 is giving amine group, so this can be possible by Br2NaOH, which is Hofmann bromide reaction. Okay, this is the very famous reaction as well. Now option number 4, we are given with the we are given with the ketone group, and it is converting to alkane. Okay, it is converting to alkane, means reduction is going here. Okay, so this reduction can be done by ZnHg, and following can consider not used to distinguish between propanol and acetone. Okay, so one is the ketone and one is the aldehyde. Okay, so which cannot be used? Okay, which cannot be used? Okay, so we can use Tollen's reagent, we can use Felling's reagent, because in Felling's reagent it gives the positive test with acetone. Okay, okay, so we can use the Felling's reagent, we can use the Tollen's reagent, we can use the Iodoform reagent. Okay, but because Tollens can give the positive for the aldehyde but not for the ketone. In Felling it will give the positive for the propanol, but it will not give the positive for the acetone, not for the acetone. Similarly for the iodoform, it required the methanol, it requires CS3 CO group for its positive test. Okay, so iodoform can also, so the remaining option, which is 2 for DNP, cannot do this. Okay, so option number C will be our correct answer. Now question number 77. Now question number 77, we are given with the benzaldehyde. We are given with the benzaldehyde and we have concentrated NaOH. We have concentrated NaOH, or you can say we have concentrated OH minus. Okay, so we have A and we have B salt. Okay, so we have to find which is A and which is B. So clearly from this hint you have to analyze that this is talking about Cannizzaro reaction. Why Cannizzaro? Because there is no alpha H and there is NaOH and concentrated NaOH. So this will be Cannizzaro reaction. In Cannizzaro reaction, this is disproportionate reaction in which we have oxidation. In this oxidation, acid will form, and we have reduction. In reduction, alcohol will form. In reduction, alcohol will form, but acid here it is talking about the salt. Okay, so we will write the acid salt. We'll write the acid salt. Okay, so the correct option will be here. We have both alcohols, the wrong option. Alcohol and aldehyde, wrong option. We have alcohol and COONA. This will be our correct option, because it is talking about the salt. Here we have alcohol, we have the acid, but it is talking about the salt. Talking about salt mean option number C will be our correct answer. Now question number 78. Identify the major product. We have to identify the major product. Okay, so we have the benzaldehyde and the attached group um, here is C double bond O, CS3 group is attached to benzaldehyde, PH CHO, PH CHO. Okay, so we have to find the major product. Here it is Tollen's reagent is given, and we know what Tollen's reagent is can do. It can give the silver mirror test, and it is also used as oxidation reagent. It is an oxidizing agent. It is an oxidizing agent. Okay, it is an oxidizing agent. So in question number 78, option number 3 will be our correct answer, because it will just oxidize this this CHO group. This CHO group will be oxidized. Okay, this CHO group will be oxidized, and after oxidizing it can form COO, minus, or you can say COOH. Okay, but according to option, COO negative will be our correct answer, because here tolerance reagent is used as oxidizing agent. So option number C will be our correct answer. Number 79, the compound which will not form iodoform on reaction with I2NaOH. Okay, so we have to check which of the following will not give the iodoform reaction. Which of the following will not give the iodoform reaction. Okay, so here are the four options, and we know for the iodoform reaction what thing is the most required. So the required thing is RCO and then CH3 group. This group is required for the iodoform reaction. If this group is present, then iodoform reaction will take place. Iodoform reaction will take place. So we will check in which of the following option this group is not present. Okay, so clearly we know we want ketone here. So clearly in option number 2 we have alcohol, not ketone. So option number 2 will be our correct answer. Now question number 80. Consider the statement given below about the compound. Okay, so we have to tell about this compound. We have benzene, then we have COH group, then we have aldehyde group on the meta position, and then we have OH group on the para position. Okay, so first of all we have to tell it will give the positive test with NaHCO3. Yes, it will give the positive test with sodium bicarbonate because COH group is present. So this group will release CO2 gas. This group will release CO2 gas, which is also known as effervescence of CO2. Okay, so first one is correct. Second is it will give positive test with 2,4-DNP. Yes, because aldehyde group is also present. So aldehyde group will give 2,4-DNP test as well. 2,4-DNP test as well. So option number 2 is also correct. Now it will give the positive test with Hinsberg reagent. No, for Hinsberg reagent we need NH2. Amine group is not present, hence option number C is incorrect. So A and B are the only correct options. Now the statement 1 is aqueous solution, aqueous sodium acetate undergo Kolbe electrolysis to form ethane gas at anode, while H2 and CO2 gas are evolved at cathode. Okay, so first of all, and the second statement is the alkane obtained during the Kolbe electrolysis contains an even number of atom. Okay, so first of all we have also discussed this reaction earlier, that CH3 COO minus Na positive, it will break in presence of electrolysis, or you can say in presence of water. Then CH3, ethane and CO2 gas will produce at the anode, and H2 gas is produced at the cathode. So statement 1 is incorrect. Statement 1 is incorrect. And now for statement 2, we have to check. In Kolbe electrolysis, even number of carbons are, yes, there will be even number of carbons. There will be even number of carbons. Clearly from the reaction you can see there will be even number of carbon. Hence statement 1 is incorrect, but statement 2 is correct. Statement 2 is correct. So option number 4 is our correct answer. Now question number 82. Among the given compound, the compound which is oxidized to prepare methyl ethyl ketone. Okay. So first of all we have ketone, then we have ethyl group, and then we have methyl group. Okay, so we want this product in our product side. Okay, so from which it can be possible. Okay, so first of all ketone group is present, means we require 2-degree alcohol. We require 2-degree alcohol for oxidation. Okay, so clearly we can check which of the following is 2-degree alcohol, and the number of carbon atoms can be same. Okay, so option number 1 will be definitely incorrect. But if you check option number 2, it is butane 2-ol, means butane 2-ol. Let me draw 1 2 3 4, and OH will be presented here. So if we oxidize this compound, then this product will form. Okay, so option number 2 is our correct answer. Now question number 83. We are given with the compound which is cyclohexane, then we have ester group present over there, and then we have a ketone group present over there. First of all we want this product. Okay, so we want which of the pairs of reactant, in which order it will give this product. Okay, so first of all NaBH4, it will reduce this ketone group to alcohol group. Okay, then dibyl H will reduce this ester group to aldehyde group. Here aldehyde group is made. Now we have aldehyde group and we have alcohol group. If we apply H plus H2O, if we apply H plus H2O, then it will remove this OH group and alkene will form. Alkene will form. Okay. So correct option will be option number 3. NaBH4, then double H, then H plus H2O heat. So we have this reactant. Now, first of all, we are reacting with NaBH4. NaBH4, it will reduce this aldehyde group to alcohol group. It will reduce this aldehyde group to alcohol group. Now, this is the product. Now, we are reacting with HCl in presence of ZnCl2. So here, this OH group will be replaced by Cl group. OH group will be replaced by Cl group. Then we have KCl. So here Cl will be attached. Now on reaction with KCl, here Cl group will be removed and Cn group will attached. Cn group will attached in place of Cl. Now we are using H plus H2O. So H plus H2O will oxidize this Cn group to the carboxylic acid group. Cn group to the carboxylic acid group, COOH group. Okay. So the correct answer will be option number 1. Now question number 85. So we are given with a match the following questions, and in column 1 we are having with the reactant, in column 2 we are having the name reaction. Okay, so we have to tell in which of the name reaction these reactants are used. Okay, so first of all, phenol. So we know definitely phenol will be used in Reimer-Tamer reaction. Very famous reaction of phenol, Reimer-Tamer. So the answer of A will be 3. Answer of A will be 3. Now acetic acid. Acetic acid is used in Hell HVZ reaction. What happens in HVZ reaction is that Cl is attached to the alpha carbon. Okay, alpha carbon of acetic acid. Now formaldehyde. There is no alpha H, so it will go with Cannizzaro reaction. Okay. Now toluene, we have Itard reaction. Okay. So matching all the option, we will get option number 4 as our correct answer. Now question number 86. Cyclohexanone can be easily converted to cyclohexane by. Okay. So first of all, we are reducing cyclohexanone means O CH3 group, OR group you can say. We are reducing this group to we are reducing this group to cyclohexane. Okay. We are reducing this group to cyclohexanone. Okay. So there is ketone group, not this group. Okay. We are given with a cyclohexanone and we want cyclohexane. Cyclohexane means this structure. So for cyclohexane, we want to reduce this. Okay, so we can't use Cannizzaro reaction for reduction. We can't use aldol condensation. We can use Wolff-Pirschner reduction. And the reactant are NH2 single bond NH2. So it can be used as the reducing agent. So option number 3 will be our correct answer. Now question number 87. Which of the following compound gives a yellow PPT on treatment with NaOH and I2? Okay, so again we are given with the iodoform reaction. Again we are given with the iodoform reaction. So we have to check whether CH3 C double bond O R group is present or not. If this group is present, then it will give the yellow precipitate, else no. Okay. So now checking all the option, we can directly say that the structure of this will have the pentanone, means it will have this structure. 3-pentanone will don't have this structure. Now ethyl alcohol can have this structure. Hence option number 4, both 1 and 3 are the correct answers. So option number 4 is our correct answer. Now question number 88. We are given with the CS3, CO, NH2, and we want to combine. We want that this group will reduce to CH2 group. This group will reduce to CH2 group. Okay. So which of the following reactant we can use? Okay. So first of all, acidic KMNO4 is used for oxidation. Hence, it can't be used. And then clearly we can see NaOH and heat. NaOH and heat can reduce this amide group to CH2 group. Hence, option number 1 will be our correct answer. And here this reaction is also given. So, okay, so we just want to separate. We just want to separate. So amide group will on reaction with NaOH will release the ammonia gas. but this NH2 group on reaction with NaOH and heat will have no reaction, so we can easily separate them out. Now question number 89. Benzaldehyde on reaction with formaldehyde in presence of concentrated NaOH give. Okay, so we can directly say in benzaldehyde and formaldehyde there is absence of alpha H. There is no alpha H. Hence Cannizzaro reaction will be there. And in Cannizzaro reaction, one product is oxidized and another product is reduced. Okay, so one product is oxidized and another produces reduced. So directly we can say option number 4 is our correct answer, because here alcohol is reduced and this is oxidized to formate ion. Okay, now question number 90. Ketones can be easily ketones can be obtained by oxidation of. Okay, so ketones we can directly obtain by oxidation of 2-degree alcohol. Okay, for 1-degree alcohol we can obtain aldehyde. From 2-degree alcohol we can directly obtain uh, ketone group. Okay, so option number 2 will be our correct answer. Now question number 91. The solubility of aldehyde and ketones in water decreases rapidly on increasing the length of alkyl chain. Okay, and the statement 2 is the boiling point of aldehyde and ketones are higher than hydrocarbon of comparable molecular mass. Okay, so first of all, analyze the statement 1. The statement 1 is correct because the solubility of aldehyde and ketone in water decreases with the increase in alkyne chain. Okay, so statement 1 is correct. Now, statement number 2. Statement number 2 is, so keeping in mind the order of boiling point, which is alcohol, then we have aldehyde, then we have ketone, and then we have hydrocarbon. We can conclude both statement 1 and 2 are correct. Okay, so this is a theory based question. Okay, so both statement 1 and 2 are correct. Okay, both are correct, hence option number 1 is our correct answer. Now question number 92. Select the structure of chromium complex formed when the toluene reacts with the chromyl chloride to give the benzaldehyde on hydrolysis. Okay, so first of all we have toluene on the reactant side and we have chromyl chloride. The formula for chromyl chloride is CrO2Cl2. Okay, now on reaction with this it will give this compound. This is brown chromium complex. Okay, and now this complex on hydrolysis will give the benzaldehyde. This complex on hydrolysis will give the benzaldehyde. Okay, so option number 3 is our correct answer. Now question number 93. Arrange the following carbonyl compound in increasing order of their reactivity in nucleophilic addition reaction. Okay, so we have discussed nucleophilic addition reaction various times. So it is directly proportional to electron withdrawing group and inversely proportional to electron donating group. Electron withdrawing group and electron donating group. Okay, so from this we can directly say, so let's check the option number 1 first. We have a ketone group on this side, we have propane group, then we have aldehyde, then we have ethanol. Okay, so first of all the electron withdrawing power of aldehyde is more than as compared to ketone. Okay, so propanol and ethanol will come, will have the higher order. Okay, and the lesser will be the chain, hence low plus I effect, hence ethanol will be have the highest, then propanol, then propanol, and then butanol. Okay, so correct answer is option number A. Now question number 94. Which of the following reagent is are used in the given reaction? Okay, so we are given with the aldehyde and we are converting to acid group, so we are just oxidizing. Okay, so nitric acid can be used as oxidizing agent, yes. Potassium dichromate, yes, we can use. Tollens reagent is also used as oxidizing agent and it is a weak oxidizing agent, but still it can oxidize to carboxylic acid group, hence option number D is our correct answer. Now question number 95. An organic compound X having molecular formula this yields phenyl hydrazone and give negative response to the iodoform test and tolerance test. It produces N-pentane on reduction. X is okay. So first of all, it is not giving tolerance test. means aldehyde group is not present. Aldehyde group is not present. CHO group is not present. Then it is also giving iodoform reaction, negative iodoform reaction, means this group CH3 C double bond O, this group is also not present. Okay, and give negative test to both. So after analyzing all these two condition and all the option, we can directly say that 3 pentanone is our correct answer. 3 pentanone is our correct answer because aldehyde group is not present, hence it will have the negative tolerance test. So option number 3 pentanone. So option number C is our correct answer. Yes, option number 3 is our correct answer. X could be yes. Now question number 96. On heating aldehyde with Fehling solution, a reddish brown PPT is obtained due to. Okay. So for an aldehyde with Fehling's reagent gives a reddish brown PPT obtained. This is due to the aldehyde are oxidized to the corresponding carboxylate ion. This is aldehyde in presence of copper, and OH group is it oxidized to RCOO negative group, and this red precipitate is made. Okay, this red precipitate is made. So option number 2 is our correct answer. This because of this group it is giving reddish brown color. Now question number 97. Which of the following reagent is are used for the conversion of ethanoic acid to ethanoic anhydride? Okay, ethanoic acid to ethanoic anhydride. So this is a direct reaction. We just have to learn this reaction because from converting ethanoic acid to anhydride to ethanoic anhydride we directly have to use P2O5 in presence of heat. P2O5 in presence of heat. Hence, option number C is our correct answer. Now, question number 98. The product formed during the Hell HVZ reaction is okay. So we know in HVZ reaction on alpha position Cl group is attached. Okay, alpha position Cl group is attached. Okay, so produced during HVZ reaction is okay. So we can directly say here, just a second. So here we have this COH group, and on the alpha position we should have one Cl group, or you can say one halogen group. So this is the only option which is satisfying. There is no halogen group. Here is halogen group is present, but on the beta position where no halogen group is present. Okay, so halogen group is present but not on alpha position. So option number 1 is our correct answer. Now question number 99. Several simpler chemical tests are given to distinguish between the pair of carbonyl compounds. Which of the following is incorrect? Okay, so we have to tell which of the following is incorrect. So propanol and propanol by silver mirror test. Silver mirror test. So this is definitely correct because tolerance test can give positive with aldehyde but not positive with ketone. So this is correct. Acetophenone and benzophenone. Iodoform test. Yes, iodoform test is used to distinguish between acetophenone and benzophenone. Okay. Now option number C, ethanol and propanol. Fehling test. No, because both group have aldehyde, so both the reactant will give the positive Fehling test. Hence, it can't be used. Okay. Now benzoic acid and ethyl benzoate using sodium bicarbonate. Yes, it will release the CO2 gas. So option number C is our correct answer. Now the last question is Cannizzaro reaction is not given by. So Cannizzaro reaction is not given by the compound which do not have the alpha H. Okay. So option number C, which do not have the alpha H. Okay, not given by. So we have to find the compound which have the alpha H. Okay, so option number C don't have the alpha H, hence it can't be our answer. Hence this also have alpha H, this can't be our answer. Benzaldehyde, this can't be our answer. But this compound, this have the alpha H, hence it can't be used. It don't have alpha H, but it have alpha H. Hence option number 4 is our correct answer. So thank you so much, guys. We are just done with the chemistry solutions.